Okay, so here's the rest of the review with the answers. Everything written in black is the answers. Everything I read out in color is how you get those answers. I'm going to go through this video rather quickly, so if you need to rewind, please do. So number 1, we have negative 2/3 x plus 9 minus 7. Remember, x is our liar, so when I write the start of the table, it's going to be a negative 9. The y's stay the same. Going down my table, I'm going to subtract 2. Going down my table on the x side, I'm going to add by 3. Remember, you can only use that negative once. Number 2, there's no parentheses with my x, so because of that, we start at time 0, which means this is our y-intercept, right? Because it's 10 is going to be with time 0. Going down my table, I'm going to add by 3 because I have a 3 for the slope, but if I need to write that in a fraction, it's over 1, and that's why I add by 1 for the x's. The next one, again, that x value inside lies, so that's why we have a positive 5 for the x's to start with. And then a positive 5 for the y's. Remember, y's don't lie, so they're good, right? They stay the same. This here in the parentheses is our start point. Okay, this is, remember, the x and then the y. I am going to be subtracting by 6 down the y side, and then if I need to change this into a fraction, I'll put it over 1, and that's why we add by 1s for the x side. Number 9, there's no there's no parentheses around the x, so that's why we start at time 0, and then that means that this negative 11 is technically our y-intercept. Going down the y side, we add by 9s because it's a positive 9 at the top of our fraction. Going down our x side, we add by 2 because it's a positive 2 on the bottom of my slope fraction. Number 5, again, the number inside is the opposite, so it's going to be a negative 10 for the start point and the start of the table on the x side. The y's don't lie, so that positive 40 stays for the point and for the start of our table. The 10 at the top of my fraction is the math I do down my y side. The 17 that is on the bottom of my fraction means we add by 17 down the x side. Number 6 is written in slope-intercept form, which basically means there's no parentheses around my x, so that means I start at time 0 for the x. This is technically my y-intercept, the negative 215. We are adding by 100 because our slope is 100, but to change 100 into a fraction, we put it over 1, and that's why we add by 1 for the x's. 7, again, remembering taking x and putting it into point slope form, it lies, remember, so that means that this is a liar, so we have to do the opposite sign, but this 10 is golden. I get the 3 because we add by 3 going down the y side, and the x side we're adding by 1. So if you write 3 over 1 on your test, I will take that. You know what you're doing. Number 8, we have 7/2 x plus 9. So we start with 0 on our table because there's no parentheses around our x because our table starts with 0. And then we start with 9, and this is our y-intercept, and that was the first value for our y's. We add by 7, so that's the top of my slope fraction, and then we are adding by 2 on the x side, so that's the bottom of my slope fraction. For number 9, again, 7 lies when you put it into point slope form, so it needs to have the opposite sign, but that 15 is golden. When we go down our y side, we're subtracting by 5, so that's why I have the minus 5 for the top of my fraction. When you go down the x side, you add by 3, so that's why the 3 is positive on the bottom of my slope fraction. Number 10, our table starts at time 0, so that's why it's just an x. This y is our y-intercept, but we write it as plus 5. As we go down our table, we are adding by 7, so I have a 7 here at the top of my fraction. But this time we're subtracting by 6 down our x. The negative really goes with our bottom of our slope fraction. If you write it as 7 over negative 6, this is still a good answer, okay? The way I wrote it is the more of the mathematical correctly written way. Number 11, 45 is a liar when we put it into the equation. 150 is not, so but remember to write your plus 50, that's important. As we go down our table, we are adding by 50 on the y side, so that's why we have a 50. On the x side, we're adding by 1s, so if you write it as 50 over 1, that's a good answer. Number 12, we start with times 0, so that's why it's just an x. This y is 100, aka our y-intercept. Please don't forget to write plus 100. As we go down our y side, we are subtracting 11, so that's why we got the minus 11 here. But on our x side, we are adding by 30, so that's why it's a positive 30 at the bottom of our fraction slope. Number 13, this is slope-intercept form, which means this is our y-intercept, which we'll find on the y-axis. This as a fraction is 3 over 1, which means we go up 3, right 1, but we can't do that. So instead, we do the opposite, which is down 3, left 1, and I do that to find all my dots, okay? Again, we have to write out the start point. That's what this is, 5, 6, and it is opposite, so that's why this is a positive 5. But this negative 6 stays a negative 6. Now remember, it's x, y. So on your x-axis, you look for 5, and then drop down to negative 6, and that's your start point, this blue one. Our slope is 2. We have to make sure fraction is 2 over 1, which means up 2, right 1. And that we can do, so that's how I get to these points here. You don't have to draw these lines. I'm just showing you like how this relates to how I got the points. This is slope-intercept form, so that means this is my y-intercept. So that's why I draw the negative 5 on the y-axis. This is telling me to go down 1, right 5, and I do that, and I get this point, and I can do the opposite movement, which is up 1, left 4. So I can go up 1, left 4. This is point slope form. This is point slope form, so that means this is our start point. And remember, our start point does the opposite of the inside x. That's why we have a negative 4, but the same as that outside negative 4. So when I plot this, I get negative 4, 4. And again, this is your start point. And then my slope is 3 over 2, so I go up 3 over 4, and I go up 3, right 4. And I do that until I can't do that anymore. This is slope-intercept form, and this is our y-intercept. Remember, the y-intercept is always the number by itself. Plot that negative 3 on the y-axis, because that's where y-intercepts go. And negative 5 over 1 is our slope, so we go down 5, right 1, but we can't go down 5, right 1. So we do the opposite movement, which is up 5, left 1. And so when I do that, I get those dots. That's how I get those dots. This last one is point slope form. So this point here that I wrote out, this is our start point. And remember, it does the opposite of the inside, but the same as that outside number, right? Because that x is a liar. And that start point, 7, negative 7, is right here on my graph. Go right 7, down 7. And then our slope movement is down to right 5, but we can't do that. We can't go down to right 5 from that blue point, so we do the opposite movement, which is up to left 5. And this is how I get to those black dots there. Number 19, 4, negative 5. I get that negative 4 from the x-axis and that negative 5 from the y-axis. This is your x and y value. And that's how you plug it into point slope form, which we've been doing. To get to my next nice point, well, that seems to happen right here. So To get from blue to green, I go up 5, right 4, and when I write that as a fraction, it's 5/4. So that's how I get these slopes here. This, however, is my y-intercept, and my y-intercept is 0. So if you write plus 0 for your slope-intercept form equation, I'll take that as a good answer. 21,3 is my start point. So when I plug that into point slope, opposite of the x. And then to get to my next nice point, that's right here. So I go down to right 1, which is -2/1. So if you write your slopes as -2/1, I will take that as a good answer. However, my y-intercept seems to happen on the 5, so this is my y-intercept. 21, our point that we were given is 2, 3. So that's 2 is my x, 3 is my y. So remember, when you plug it in, it's the opposite for the inside the point slope form. When I go to my next nice point, I'm going down 1, right 2. So when I write that as a fraction, down 1, right 2. So that's how I get these slopes here. And then my y-intercept occurs here at 4. That's where my graph passes through the y-axis. So that's where I write +4 for the slope-intercept equation. 22, my start point's 4, 4. So that's my x, that's my y. So remember, opposite of the x is a liar, so you do the opposite. The y is not. The next nice point is right here, which means I go down 9 and left 4. Well, if I go down 9 and left 4, that gives me 2 negatives, and 2 negatives make a positive. So that's how I get 9/4. And then this nice point is also my y-intercept, so that's why I have a negative or a -5 in my slope-intercept form of the equation. Everybody liked to distribute, so we're going to just do distributing only. Our slope is -4, so when I plug it in the point slope, here's my -4. My x is a -6, and remember, it's a liar, so that's why we have a +6, and then -2 is good. We distribute, so -4 times x is a -4x, -4 times 6 is a -24. Combine like terms, and we get -26. So that's why our slope-intercept is y is equal to -4x minus 26. Number 5 here, our slope is 5, and our x value is 10. Our y value is -15, so we have to do the opposite because x is a liar. When we use point slope form to distribute, 5 times x is 5x, 5 times -10 is -50. -50 minus 15 gives us that -65. So that's why our slope-intercept form is y is equal to 5x minus 65. For the word problems here, after getting caught roaming the halls during math class, the AVS had 16 missing assignments during week 12 of school. Every week he completes 3 more assignments. So I get this 12/16 because he already had 16 missing assignments during the 12th week of school. As I go down my table, I subtracted 3 because he's completing 3 of these assignments, and I'm adding by 1 on my x side because he's completing 3 assignments every week. So here's the point slope form of this equation. You guys are handling that really well. If you put that -3/1, I will take that. Then I took my point slope form and I distributed to figure out my slope intercept. So -3 times x is a -3x, -3 times -12 is a positive 36. 36 plus 16 gives us that positive 32 that's right here. And this is the slope-intercept form. To figure out why he has 1 missing assignment and to show your work, I have to figure out week 17. So we start at week 14. After that would be 15, 16, 17. Then we would have 7 for 1. And that is how we get the 1 missing assignment. You must show your work. 26, Amaya was practicing her shooting technique for basketball on Friday. After 8 minutes, she had made 24 baskets, and every 2 minutes she makes 7 more. So after 8 minutes, she had 24 baskets. So that's how I start my table. Every 2 minutes, she makes 7 more baskets. So let's do that in a different color. She makes 7 more baskets. So that's how I get this information. And then from there, you can actually write your point slope of the equation, right? You guys have been doing this. You're amazing at it. For the slope intercept form, you could use distributing, but it might be a little bit difficult. I actually went backwards on the table. So above 8 is 6, then 4, then 2, then 0. And then above 24, so let me draw some lines here so you guys can see what I'm talking about. Above 24 is 17, above 17 is 10, above 10 is 3, above 3 is -4. So at time 0, we have a -4. And that is how I got this -4 in the slope-intercept form. And then it says how many baskets in 20 minutes. I said 66. To show my work, I bring down my table, 14, 16, 18, 20, which gives us 45, and then 52, and then 59, and then we get 66. So in 20 minutes, she had 66 baskets. Error analysis. So India studied really hard for a math test, but she made a tiny error when writing slope-intercept form, right? So we are adding by 6 as we go down our table. And when India went backwards, right, she had 0, -3. Okay, so that's where this -3 comes from. But what India messed up is she wrote -6. She changed the slope. You can't change the slope from going from point slope form to slope intercept. The slope does not change. So that's why it's just y equals 6x minus 3. Skip the problem about Mark here, and we'll go to the one about Miss Bailey and Miss Rowell. They were writing their answers, but all the students got it another way. In reality, they both made a silly, super common mistake. So we wrote the problem in point slope form, right? The slope's good. They did the opposite of the x. That's okay because x is a liar. This 20 is good. So next up, we have to see what math they did. So -7 times x is a -7x. That's good. -7 times 10 is not a positive 70. That's where they messed up. -7 times 10 is -70. So that's where we messed up. From there, 70 plus 20 gives us a -50. So the slope-intercept form is y is equal to -7x minus 50. All right, that's the end of this video. I hope you guys study hard, and I'll see you in class for tests.